to my first video on radar. This is my introduction to radar, and I figured that the best thing to do is to hold off until I get my hands on to a radar system. This came off a pilot boat. Took it off and replaced it with a much more modern radar. This is the Furuno FR-8111 radar system, and Furuno radars are incredibly reliable. I mean, I really haven't seen a dud yet out there in Furuno. Very reliable, very rugged. This guy right here gave faithful service, I guess about 20 years. I'm basing it on the condition of the front of the array, the antenna array. It's the gel coat's totally gone. I can't date this system, but with Furuno systems and a lot of other systems, the model number, like this is a 8111. It consists of a RDP112 display, which actually has a processor, the high voltage for this thing, and a bunch of other circuits. We'll go through them when I dismantle it. And then they got the scanner right here. That's the bottom part of the antenna assembly, and that is a C2P7121. I've never come across one of those. Got into the marine electronics business in '07, and I've kind of been in and out of it between now and then. They run me away, but I seem to come back to it. I actually like this stuff. I like the insanity. I hate the drives. But the combination of these two, or say three, with the array also, makes the Furuno FR-8111 radar. So what I'm going to do now is cut away. I'm going to set things up so that I can start dismantling it. I'm going to start off with the scanner itself. I think next I'll do I'm going to do the display next. And if I can successfully dismantle this array within short order, I will cover that last. So let's stand by. Alright, here we go. Here's a scanner unit, and I'm going to start off with the top part right here. This is called the rotary joint. You see this can rotate. Bottom is waveguide. This is the best method for transmitting microwave energy. This is an X-band radar, and it's around 9 gigahertz, up a 9 gigahertz, 10 gigahertz range. It varies. There's no really solid frequency that you're assigned with a particular radar. These guys create a lot of noise, radio frequency noise, so there's, but this is the rotary joint, and this enables it to go round and round, the antenna go round and round, and have a continuous connection between the antenna itself through this waveguide. Now we'll cover this later on in greater detail, and then later on after that I'm going to go into it with excruciating detail, and probably I'll come and approach it again from an engineering aspect. So just prepare yourself. Most of y'all really don't need to go past the second video on waveguide. First video we'll do it for the technicians. Alright, so yeah, you got the whole assembly. You can feel the gears and the motor going in here, and it's still relatively tight. So we pull the covers off. I'm going ahead and loosened up a lot of stuff just to make it easier, we don't want to spend a lot of time dismantling things on a video. Nice big heavy chunks of aluminum. Furuno really makes good strong stuff. So you can see the gasket in here. Very strong, reliable gasket. When you're dealing with radars, Furuno radars, they use this brown grease. It's a basic pure grease. You can use regular grease to substitute after the fact. As long as molybdenum grease, you want to avoid that. You want to have a clear grease or not lithium grease. Well, yeah, you can have lithium on it, lithium grease, but no molybdenum. That stuff will get in there and it become conductive. Bad news. And you can see that the seal at the top is failing. I don't know if you're gonna be able to see it on here, but you can see rust is around in here. So this radar was the scanner itself was on the way out. The reason that it was replaced is the CRT power supply had failed, and I actually considered repairing that thing troubleshooting repairing it before making this video, and I said, nah, that's like 5 hours or more just to troubleshoot it. It does have a decent service manual, so that would have helped me a lot with troubleshooting, but this thing's obsolete. This thing is horribly obsolete. You know, you put money, if you put any money in these things, you're you basically having a 20-year-old radar, a very expensive 20-year-old radar. And I would love to help the customers out there, you know, in a real pinch. And I may go back and make up a test jig or something to test or reassemble the display and troubleshoot it later on, because customers are all very important to me. That's the reason I'm here. But at this point, I just want to tell you this is important to educate people, because we do have a really bad shortage of technicians out there. Now, the Furuno radars, well, almost all of them, the NavNet ones that open up like a clam, they don't have this, but all the ones that open up from the sides, the radars, the bulk of the radar comes out in a sled. I love this. So you just undo this, you undo the wires, and out it comes. You got the whole TR, transmit receive assembly. You can see the various parts that kind of like get dumped inside. You look at the other side, here's the motor. Now, when the radar is going round and round, the processor needs to know where the antenna's at. Back in the old days, we used synchros and resolvers. When I was in the United States Navy, our radars used synchros and resolvers to determine their position. And I believe even the most modern ones that rotate use synchros and resolvers, but that's expensive. What this guy has is a optical interrupter and the sensor right here, just like you'd see in your printer. I mean, exactly the same as you see in your printers. That as it goes along, the things move, it can count it, you know, step, the way it's at. And that's what this has. And then right here, there's a read switch. Just like you'd see in a, you know, a door or something like that, you know, alarm system. And when the scanner, the array goes past north, there's a little magnet right here, and it says it's when it points to bound, or when it points where it's at right now. So the counters, the bearing counters in the processor synchronize themselves with this. The motor that spins, it's a pseudo, you know, free running. It's a free running situation. So its rotation is approximate, but the little phase lock loops in there, or digital loops, will take and sync up to it. That works out pretty good. This is a permanent magnet type motor. Let's see. And we got some wear on it. You can see it's a little bit carbon in the bottom. That's typical. The it looks like, ooh, it looks like holy cow. This can't be. The motor itself, look at the brushes. Wow. I'm looking at the evidence before me. I see the motor right here. This is a real deal Furuno motor, because it's got the writing on it that tells you what color wires go where on this thing. It looks like it doesn't have a huge amount of wear on it. That's really incredible. That's very shocking to me. I'll put this brush back in, because I'm gonna hang on to this motor, which probably is gonna bounce around on my truck. I love to keep certain things in there, and this is going to be one thing that I'm going to keep with me. And you know, you just never know. You never know, you know, when you're going to need something to get a customer working again. And when these bolts don't work, they don't make money. You know, it makes them really unhappy. So that's just one thing. But original paint marks on this thing, the paint marks line up. It looks unbroken. The motor's original Furuno. I'm really wondering if this is the original motor. Wow, that's something. So here we go. Here's the TR assembly, and let me give you a closer shot of it. You can see the connections there. On the bottom of here is a modulator and a magnetron, and on the top is the IF. So let me pop open the bottom first. Oh, there's a waveguide connector that mates up with this right here. So that's how it actually connects. So look at this stuff. Most techs will say that the synchronizer is the heart of the radar. And it's true. That's in the process, and that synchronizes everything up. But I like to think that the magnetron is the heart of the radar because it makes the energy. And the magnetron has a really incredible story at the beginning of World War II and through World War II. Quite the war-winning weapon. I don't think that the war would have played out the way that it did. So here we go. Here's the inside. You can see here's the magnetron. This is what makes the energy. This here's your modulator. Your transformer right here. It provides a filament voltage between these two. It's been changed. You can see right here. It's been changed. And the person that changed this magnetron didn't do it well. These two wires right here should be as short as possible. I mean, really as short as possible, because they have high voltage and high frequency energy on them, and this will walk across. And I recently went on a boat that sustained significant damage to its scanner. In fact, that was a Furuno 2137, an S-band. So it's about a $30,000 scanner. And the burning of all this right here allowed corrosive chemicals to get around and damage some other stuff on it. It's really a shame. But yeah, so this is your modulator. These right here are SCRs, pulse forming network, magnetron. Let's go on the other side. What am I missing? At least I'm much holding this thing in place. Oh, I do need to take these guys loose. Okay. Oh, look, somebody put an arrow right here so they can know which way it goes. Yeah, buddy. So if any of y'all, want to make money, get treated pretty good. It can be stressful. Travel, drive all over the place. Marine Electronics is a place to go. So here we go. Here's a little more of it right here. You can see this is called the circulator. And so you see the magnetron right here? This is where the antenna goes, and this is a receiver. So with the circulator, the energy will go from the magnetron in this port, and it'll come out this port. The energy coming back from the antenna, the receiver signal goes in this port, comes out this port. If you actually put power in this port, it would come back down where the magnetron's at. That's why it's a circulator. What goes in port 1 comes out 2, what goes in 2 comes out 3, what goes in 3 comes out of 1. This right here, I'm not quite sure. I'm assuming this is a diode limiter. It could be what's called TR tube in there. A TR tube is a gas cell that ionizes with the energy from the magnetron that protects the front end. And then this right here is the IF. So let me expose these parts. Okay, so here we go. On this side right here, on this side is the what's called the MIC. I think that stands for Microwave Integrated Circuit. This has the front is actually the front main part of the front end of the receiver. It has a local oscillator inside of it, a mixer, and so it mixes the input, the signal coming back, with the local oscillator, creates an intermediate frequency, and that goes through the IF amp right here. So I'm going to pull that off right now. I sure love taking things apart. I actually enjoy putting them back together and seeing them work again. Unfortunately, this thing will never work again as a whole unit. Alright, my screw collection is going to grow. You should always carry a nice assortment of screws with you. And since we, in our main product line at Power Radio is Furuno for the communication and navigation, that's handy. So here's your intermediate frequency amplifier right here. Let's see if it'll focus. Whee. So you can see all the components of surface mount, even the electrolytic capacitors. Here's the thermistor that comes in, that's measuring the temperature. You got only a few of these transformers, or well, let's see, they all say T, so I'm guessing they're all transformers. So you have 4 of those. Very little to it. Years ago, it would have been much bigger. You got components on both sides. This is double-sided components. It looks like it actually got repaired too at some point, because I'm not sure. Oh well. We keep on moving, onward and onward. So let's go after the magnetron. My friend the magnetron. What I'm going to do is just cut this loose, because anything that this thing goes into I'll have to trim the wires back. But yeah, this looks like a pretty new magnetron. In fact, I wouldn't be surprised if the customer had the magnetron changed recently. That's what they do when the when things start going wrong. They'll have a lower level company come in and work on that stuff, and if they don't get it, they'll hire somebody else. So here we go. Here's a magnetron. It actually has magnets in it. What I'm gonna take and now later on I'm gonna take a bad magnetron and I'm gonna dismantle it when I cover magnetrons. So here's your pulse and filament transformer. This part is part of the pulse filament network. And when I come to pulse filament network, you can see it simulates a section of transmission line. And that's when module 10 covers transmission lines. That'll give you a good primer for that stuff. But I'm gonna cover that module in great detail. I haven't done that yet. In fact, I've finally gotten over my stage fright. This is actually kind of terrifying for me. But I'm pretty motivated to have some new blood come into the marine electronics industry. Electronics industry, period. The average age of a component level troubleshooter such as I is in the 70s. As you may guess, it's pretty hard to maintain that. People are retiring and dying, and you can't hire dead people. So here's the modulator. You'll notice that it's done with through-hole technology. You have a little daughter board or whatever here, daughter board, that's surface mount. But overall, and the reason you do that is this is higher voltage stuff. Higher voltage, higher current. So when you get to that, you'll often see you get back to the through-hole technology, just because of the heat that's involved. So let's go after the mic now. And these mic modules are a real game changer, because prior to them you would have to send sections to get repaired at Furuno or whoever it is. But you can see right here, here's a mic module. You can see the waveguide coming in. Everything in the microwave range is going through waveguide. It's just a little block. I'm going to dismantle one. I'm going to get my hands on one that has failed. I'm going to hang on to this one, keep it in my truck. You know, you just never know. They're not big, they don't take much space, and I've got it. Alright, so I've finished tearing apart the radar scanner. It's got a big old hole through it now, and the only thing I didn't take off was the mounting, the rotating assembly that holds the antenna. I'm gonna have to press that apart, and you know, I can get all this aluminum and give it to my Aunt Carol to take and donate to the puppies at the Picayune animal shelter. They collect aluminum and sell it for you know, to help their operation. So I always try to help them. So okay, here's the circulator. 3 ports, 3 waveguide ports, and you can see right here. Let's see, can you see it? There's a little arrow, and you got numbers on it: 1, 2, and 3. So what comes in 1, just like the arrow says, comes out 2. What goes in 2, as the arrow says, comes out 3. What goes in 3, comes out 1. Pretty straightforward stuff. And for comparison, different frequencies. Here's a well, this right here is X band. This is straddling 9 and 10 gigahertz. So most of these radars are running in the upper part of the 9 gigahertz band. And this is a circulator that came out of a 7 gigahertz studio transmitter link. This is from when I worked at Channel 6. The whole transmitter site went underwater, and you know, I was free to salvage all kinds of stuff. So this is right at between 6 and 7 gigs, right across there. So you can see the waveguides considerably smaller for the X band than the 7 gig. I'm not sure what letter designation that would be. And this is S band. This came out of a weather radar at Channel 6, which went underwater. And this is a Type N connector. I believe this one came out of it. This one, I might have bought this one on eBay. I don't remember. But you can see the it's even larger. This is around 3 gigahertz, possibly 4. Up in that range. That's where weather radar is at. and the ships have S-band radar. S-band radar can see through weather better. That's why they're forced to spend extra money to get that big radar. It's about $60,000 for an S-band radar, which it's really expensive. But if you want to be on be a soulless boat, you got to have a radar for it. So earlier in the video, I was talking about whether it had TR tubes or diode limiter. Well, this is my answer right here. This is a diode limiter. So unfortunately, it don't have TR tubes, which is the older technology. I lost everything in Katrina, including my collection of TR tubes and magnetrons, all my show and tell stuff. So hopefully I'll get hold of something really old and get me some TR tubes to show off. But so you got your circulator. Now, if you put the magnetron right here, okay, and the antenna right here, so the power comes into the circulator, goes like the little arrow, comes out the antenna. The signal coming in from the antenna will go, like the arrow says, out of here. And then you'll have this little assembly right here, and then your diode limiter and your MIC unit. Your MIC unit is the first part of the front end of the radar, the receiver. So that's the gist of how all this goes together. It's really simple. It's just a bunch of blocks. And just like when you learn a new city or something like that, you move to a new city, you learn how to get to and from work and the grocery store, and if you drink the bar room, I don't, but that's what it boils down to. If you're going to be a technician working on radar, you really should have a deep knowledge of the theory behind it, but you don't need it. And but it really comes in handy when you're troubleshooting out there. And another thing I found really interesting with this guy right here. This is that piece that I thought had TR tubes in it. The waveguide actually splits open, and that's the first time I've ever seen anything like this. I've never seen a piece of waveguide, and I've torn into a whole bunch of microwave systems. And what you're seeing here, and I'm going to cover this in my waveguide sections, that's what's called a choke joint. You can see another one right here. And what you're going to learn, or hopefully already know, is that a choke joint reflects. Just like SWR, you do your reflected power when you evaluate a radio antenna or something like that. This here will reflect a short to the interface right here. And by reflecting that short right there, you dramatically reduce the leakage of microwave energy. Really neat little thing. But I'm going to tear apart this rotary joint. It's going to probably take some pressing. I don't see it coming apart without some heavy duty toolage. And I'm going to show that in my video later on. So I'm going to take all these parts, and I'm going to describe them in greater detail, part by part by part by part. And then I'm going to come back and go deeper into the theory of certain areas. And then I'm going to go even deeper into the engineering level. Most of y'all don't even want to look at this. It's going to make your eyes glaze over. But and I'm going to have to actually research it before I go into it. I've been through this material before many times, and every time I've got to research it, so I can get it accurate. But that's the really thing, is that when you understand the theory behind how these devices work, these radars or radios, all this, you don't need to call up that theory. You're not going to create a mathematical model out in the field. But by understanding it, it really aids in the troubleshooting process and actually the enjoyment. I mean, there is a lot of enjoyment in working on things. So I'm going to close this video out. I'm going to come back and do the video on the scanner. I mean, not the scanner, on the display. And that's going to be a little bit shorter. And the individual parts of the display unit I will be explaining in subsequent videos. And, it's going to go down. But I'm also going to cover the same material in microwave videos. I'm going to cover feed lines. I'm going to cover, in fact, it's going to go with the niche manuals. I'm going to cover felines, waveguides, antennas. I'm going to cover microwave devices, and I'm going to cover radar. This right out of the NEATS manuals. And so download the NEATS manuals as you go along in your studies. And I'll be going along. The only ones I won't be going step by step through will be the ones on AC, DC circuit, solid state components. I haven't reviewed the ones on the receivers, transmitters, stuff like that, but I may be following them. It's been a few years since I looked at them. So, but for the basic electricity electronics to grow textbook is excellent, and that's why I went with it. And but that doesn't mean you can't download and use the actual NEAT manuals, because they're pretty good, but there's a lot of stuff missing and it can be explained a lot better. So I'm looking forward to you watching my video on the display unit. Thank you.